Hello guys, in this video we'll be going through integration using the U substitution method. We use the U substitution method when we have a function and its derivative inside the integral. So the first question, we have the integral of x squared multiplied by sec squared of x cubed dx. We let U equal x cubed. We differentiate the U, so the derivative of x cubed will be equal to 3x squared dx. So we have an option of making the dx as the subject of the formula, or we can rearrange our integral as the integral of sec squared x cubed multiplied by x squared dx. And from here we use the mirror method, where we can see that we have x squared dx here, and also we have x squared dx as part of the du. So in order for us to substitute x squared dx, let's divide through by 3, such that you have du over 3 is equal to x squared dx. So in the place of this x squared dx, we will substitute du over 3. So our integral will be the integral of sec squared. So we say that x cubed is equal to u. So in the place of x cubed, we substitute the u. And in the place of x squared dx, let's substitute du over 3. We rearrange our integral as, so we take this 1 over 3 out of the integral because it's a constant, and we'll be left with sec squared u du inside the integral, and the integral of sec squared u du with respect to u will be equals to tan u plus c. Our integral was in the form of dx and not du, so let's substitute back the x cubed in the place of u, and this will be our answer for the first question. For the second question, we have the integral of cos of x plus 9 dx. In this case, we have to let the x plus 9 equal to u, and we differentiate u, so the derivative of x is equal to 1 and the derivative of 9 is equal to 0 dx. So our du will be equals to dx. So in the place of dx, we will substitute du. Our integral will be equals to the integral of cos of u. In the place of dx, we substitute du. So the integral of cos of u will be equals to sin u plus c, and we substitute back the x plus 9 in the form of u because our and this will be our answer for the second question. Question number 3, we have the integral of e to the power x divided by 4 plus e to the power x raised to the power 3 dx. In this case, we let u equal 4 plus e to the power x. We differentiate the u. The derivative of 4 is equal to 0 plus the derivative of e to the power x, which is just e to the power x dx. We have an option of making dx the subject of the formula, but we can see that we have e to the power x multiplied by dx here. So in the place of this e to the power x multiplied by dx, we substitute du because we can see that it is equals to e to the power x dx. So our integral will be equals to 1 over u. So the 4 plus e to the power x is raised to the power 3. So we also raise the u to the power 3 du. So we'll have the integral of u to the power negative 3 du. From here we integrate. So the integral of u to the power negative 3 with respect to u will be equals to u to the power negative 2 divided by negative 2 plus c, and this will be equals to, so let's take the u to the power negative 2 and move it to our denominator, and the exponent is going to change sign from negative 2 to positive 2. Our integral was in the form of dx, so let's substitute back the 4 plus e to the power x in the place of u, and this is raised to the power 2 plus c, and this will be our answer for number 3. Question number 4, we have the integral of x plus 4 raised to the power 4 dx. So this will be very tricky if we were to say that we are going to expand. So let's just let u equal x plus 4. We differentiate u, so the derivative of x is equals to 1. The derivative of 4 is equals to 0, so 1 plus 4 is equals to 1 dx. So our du is equals to dx. So our integral will be equals to the integral of u raised to the power 4 du. The integral of u to the power 4 will be equals to u to the power 5 divided by 5 plus c. Let's substitute back the x plus 4 in the place of u. And this will be our answer for the 4th question. Question number 5, we have the integral of 3x into the square root of 2 plus x squared dx. So we let u equal the inner function 2 plus x squared. The derivative of u will be equals to the derivative of 2, which is 0, plus the derivative of x squared, which is equals to 2x dx, and we can let dx be the subject of the formula, or we can try to mirror what we have inside our integral with what we have as our du. So let's rearrange our integral as the square root of 2 plus x squared x dx. So in the place of this x dx, let's substitute, after we divide through by 2. So in the place of x dx, let's substitute du over 2. So our integral 3 multiplied by the square root of u multiplied by du over 2. Let's take the constants out of the integral, and we rearrange u, the square root of u, and we write it as u to the power 1 over 2 du. The integral of u to the power 1 over 2 will be equals to u to the power 1 over 2 plus 1 divided by 1 over 2 plus 1 plus c. Three over 2 will cancel out with that 3 over 2, and we'll be left with the integral of the square root of u to the power 3 plus c, and we substitute back 2 plus x squared in the place of u raised to the power 3 plus c. For the final question, we have the integral of cos x multiplied by e to the power sin x dx. In this case, let's let our u equal the sin x. We differentiate u. The derivative of sin x is equal to cos x dx. Either we make dx the subject of the formula or we rearrange our integral. We have cos x dx, and also our du is equals to cos x dx. So in the place of this cos x dx, we will substitute du. So our integral will be equals to e to the power u multiplied by du. The integral of e to the power u is equals to e to the power u plus c. Let's substitute back sin x in the place of u plus c. This will be our answer for the 6th and the final question. If you have any questions, you can leave them in the comment section below. And if you find this video useful, consider subscribing, liking, and sharing this YouTube channel with your fellow mates.